Welcome to the Padhai Karlo JEE preparation channel. You can practice more problems on this exact topic on our Android P-Bill below or on our website padhai.com. Today's topic is the reactions of alkanes, combustion. Let's begin. Alkanes genuinely undergo combustion when burned in excess oxygen, producing carbon dioxide, water, and releasing a genuinely large amount of heat. This specific highly exothermic property is exactly why alkanes serve as the primary fuels in petrol, diesel, and cooking gas. With a limited oxygen supply, incomplete combustion genuinely occurs instead, producing carbon monoxide or even plain soot, elemental carbon rather than carbon dioxide. This is genuinely why a yellow, sooty flame signals incomplete combustion, while a clean blue flame signals genuinely complete combustion with sufficient oxygen. The general combustion equation for an alkane, CnH2n+2, is genuinely balanced by producing NCO2 and N+1 H2O for every 1 mole of alkane burned completely. Halogenation genuinely replaces one or more hydrogen atoms on an alkane with halogen atoms through a free radical substitution mechanism initiated by ultraviolet light or heat, which first splits the halogen molecule into two reactive halogen radicals. This reaction proceeds through three genuinely characteristic stages: initiation, where the halogen radical first forms; propagation, where the radical repeatedly reacts with the alkane and regenerates a new radical each cycle; and termination, where two radicals finally combine and stop the chain. Controlled oxidation using a catalyst like manganese acetate at moderate temperature can genuinely convert an alkane directly into an alcohol, an aldehyde, a ketone, or a carboxylic acid depending on the specific reaction conditions used. This genuinely provides a route from otherwise unreactive alkanes into much more chemically useful functionalized organic products. Cousteau's frequental leady halogenation product, when multiple types of hydrogen are present, odd order for hydrogen be more shamil greater than secondary greater than primary, since a more substitute radical is generally more stable. So preferential places hydrogens at the more substituted carbon position. A frequently tested trap involves genuinely fluorination being far too violently explosive for practical, controlled use, while direct iodination is genuinely too slow and reversible to be synthetically useful, making chlorination and bromination the two genuinely practical halogenation reactions actually tested and used. Also remember that combustion is fundamentally an oxidation reaction itself technically. So questions combining combustion with the separate controlled oxidation pathway are genuinely testing whether you can distinguish complete oxidative destruction from partial, controlled functionalization. Let's recap. Alkanes undergo complete combustion to carbon dioxide and water when oxygen is plentiful, or incomplete combustion to carbon monoxide or soot when oxygen is limited. Halogenation proceeds through a free radical substitution mechanism with initiation, propagation, and termination stages, favoring the more substituted carbon since tertiary radicals are most stable. Controlled oxidation with a catalyst can functionalize alkanes into alcohols, aldehydes, ketones, or acids. Knowing the radical stability order and which halogens are practically useful are the key skills this topic tests. That's combustion, halogenation of and oxidation of alkanes. Keep the radical stability order and the free radical mechanism stages sharp. They're the fastest way to predict major products on the exam. If this video helped, please like it and subscribe to Padhai Karlo for more JEE preparation content just like this. See you in the next one.